Hi, welcome. In this video, we're going to review problem-solving techniques for the confidence intervals that we learned in Chapter 8. So I'm going to share my screen and start off just looking at the formula card. So for this irregular formula card, for Chapter 8, we see that we have two interval procedures over here, the Z interval for mu when sigma is known. Right, and I have a formula here, and the T interval for mu when sigma is unknown, and this then has a T sub alpha over 2. When you're doing the Z interval, you're using the Z sub alpha over 2. So the question becomes, one of the important questions becomes, is sigma known or is sigma unknown? Okay, and so we're going to look at the two problems that we'll be doing in this review, and look at the wording in the problems and determine which interval, which procedure to use for each of the problems. Okay, so the first one says on a certain platform, the length of videos for baking sourdough bread have a normal distribution with a sample of 9 videos is taken, and the sample mean video length is 22.3 minutes. The population standard deviation is known to be 1.1 minutes. Find and interpret the 95% confidence interval for the population mean video length. Okay, and so the question is sigma known? Because if the sigma is known, then we'll do the Z interval. Is sigma unknown? Then if the sigma is unknown, we would do T. So look back here. Oops. Look back here and we'll see. I will go to the word standard deviation in the problem and look at what the adjective is or what's explaining the standard deviation. And in this sentence says the population standard deviation is known. Population standard deviation is sigma. And so in this problem, sigma is known, we'll be doing a Z interval. Let's look at the second problem and determine which interval procedure to use, and then we'll go to the whiteboard and do them both. Okay, so this is about weights of apples from a local farm are normally distributed. A random sample of 20 apples is taken and their weights are recorded. The sample has a mean of 8.1 ounces and a standard deviation of 2.1 ounces. Find and interpret the 99% confidence interval for the mean weight of apples. Okay, so let's go back to the word standard deviation, and we have to determine if this standard deviation is the population standard deviation. Two ways which we would know that is if it was referred to as population standard deviation, as in problem 1, or if it's referred to as sigma, right? Because that's the notation for that, for population standard deviation. But in problem number 2, we see standard deviation, and we go back and we see that this comes in the sentence here. The sample has a mean of 8.1 ounces with a standard deviation of 2.1 ounces. So this is a sample standard deviation because this standard deviation comes from the sample. So for the second problem, we're going to do the T interval procedure. Okay, let's go on over to the whiteboard and get to work. I reproduced the formulas that we're going to be using here. And you can see on the formula card that we have this form where it's written as x bar plus or minus Z sub alpha over 2 times sigma over the square root of n. And I always really like to write it out as 2 separate terms with a comma in the middle. So an upper bound and a lower bound of the interval. And that means the lower bound has the minus and the upper bound takes the plus. Okay, so let's look at the first question. We're going to use this Z interval procedure. So what we'll do is we know we need an x bar, we know we need a sigma, we know we need an n, and we do need a Z sub alpha over 2. So let's go ahead and write down the values that we need. And we do need Z sub alpha over 2. Reading the problem, On a certain platform, the length of videos for sourdough bread has a normal distribution. A sample of 9, n equals 9 videos is taken. The sample mean is 22.3, so 22.3 minutes. The population standard deviation is known to be 1.1 minutes. Okay, and we are told to find and interpret the 95% confidence interval. Okay, so it's from the 95.9, the confidence level is 0.95, and it's from that we're going to sweep through or work through to determine what our Z sub alpha over 2 is. So I'm going to draw here a picture of what this means, not to be 95% confidence interval, how we put what the Z sub alpha over 2 is. Okay. So if that's the standard normal, and we know we're going to use standard normal because we're doing a Z interval procedure. Okay. And so we have the standard normal curve, and we want to know that what this value is here. What is the right tail delimiting value? If 0.95 is in the middle, okay? And so what we need to do is determine how much is in the right tail, and then we'll go over to the table and we'll get our Z sub alpha over 2. Okay, so alpha is the total amount in the two tails, right? So that's 1 minus 0.95. Right, and then we want to put it over 2 because we want just the area in the right tail. So it's 0.05 divided by 2, or 0.025. Okay, and now our Z sub alpha over 2 is actually Z sub 0.025, and we're going to go over to the formula card and find that value. Actually, we'll go to the bottom of the T table here. So, because there's a little box, a convenience box. Okay. So sharing screen. I'm going to scroll all the way down to the last page. This is the T table, and we like this little box here because we're looking for Z sub 0.025, and we can see it's right there at 1.960. Okay, so I'm going to go back to the whiteboard and let's work on that calculation. So we have Z sub alpha over 2 is equal to 1.96. Okay. All right, good. So what I'm going to do is, now that I have that, I want to move the calculations over to the here. So it's X bar minus Z sub alpha over 2 times sigma over the square root of n, to X bar plus Z sub alpha over 2 times sigma over the square root of n. And you'll notice on the question sheet, I said, be sure to show Z sub alpha over 2 or T sub alpha over 2, your margin of error and an interpretation. So the margin of error is going to be this piece here. So we'll start by substituting in 22.3 minus 1.96. Times 1.1 over the square root of 9 to 22.3 plus 1.96 times 1.1 over the square root of 9. Okay, so we want to calculate that piece first. So calculators, please, let's give it a try. This time we have square root of 9, so that's 3. It makes the calculation a little bit easier. And I'm getting 0.7. We'll just take it to 0.72. Okay, and that is my margin of error, right? So let me note that. Margin of error is equal to 0.72. These are minutes. Okay, so Now that we have the margin of error, we're going to subtract it from the sample mean. Oops. Okay. So subtracting. The lower bound gives us 21.58, and adding here, the upper bound gives us 23.02. And the last thing we have to do is interpret the interval. Okay. So how about I interpret the interval over here? We are 95% certain that the population mean length, video length, is between 21.58 minutes and 23.02 minutes. Okay, so 3 steps to the problem. First was to determine your z sub alpha over, well, actually 4. First to determine whether you're doing a z interval or a t interval, right? But then you calculate your z sub alpha over 2, right? So that's one part. And then substitute in and solve, and then interpret. Okay, so we're going to go on to the next problem. Okay, and so we decided that the problem about the weight of apples, we were going to use the t-interval procedure. So I'll go ahead and pull out the values that we need. So we need an x bar. Oops, actually, guys, this should be an S. Sorry about that. We're using the t-interval procedure because we don't know sigma. So we have to indicate that in the formula appropriately. Okay, so x bar, S, N, and then we're looking for T sub alpha over 2. And this is this has degrees of freedom equal to n-1. So let's go ahead and read. Weight of apples are normally distributed. A random sample of 20 apples, n equals 20, is taken and their weights are recorded. The sample has a mean of 8.1 ounces. So that's a sample mean. And the sample has a standard deviation of 2.1 ounces. Okay. And we are asked to find the 99% confidence interval. So the first thing we have to do is, so our confidence level is 99%. Okay, let's draw the picture. We'll find the T sub alpha over 2. So this is T. It has degrees of freedom equal to 19. And we need to figure out what's the delimiting value so that the center area is 0.99. We'll figure out how much the right tail is, alpha over 2, and then we'll find this from the t-table. So if we have 0.99 in the center, then the 2 tails together is 1 minus 0.99, right? And the right tail is 1 minus 0.99 over 2. So it's 0.1 over 2, 0.01 over 2, which is 0.005. So let's go on over to the t-table. Take a quick moment here. Remember, we're looking at 19 degrees of freedom. And so, and we're looking at the rightmost column, T sub 0.005. And this should be our value, 2.861. Okay, So the T sub alpha over 2 is 2.861. Great. So let's go ahead, work with the formula and substitute in. So the T formula is x bar minus T sub alpha over 2 times S over the square root of n to x bar plus T sub alpha over 2 times S over the square root of n. Substituting in 8.1 minus 2.861 times S, which is 2.1 divided by square root of 20. Okay, and 8.1 plus 2.861 times 2.1 over the square root of 20. Okay, so we're gonna solve. First, we'll solve for the margin of error. Okay. Probably getting the square root of 20 is a good way to get started with that. Take a moment, please take the calculators out. Make sure that we can get efficiency, or accuracy, numerical accuracy by practicing with the calculator. Okay, and so my margin of error, I'm getting 1.34. So lower bound 8.1 minus the 1.34 margin of error, and upper bound 8.1 plus 1.34. Okay. And so subtracting here, we get 6.7. Just check with the calculator. Please work along. We all get the skills. I certainly need the practice always. 8.1 minus 1.34, 6.76, and 8.1 plus 1.34 is 9.44. That's our upper and lower bound. And the interpretation is we are 99% confident that the population mean weight, apple weight, is between 6.76 and 9.44 ounces. Okay. So again, first thing we have to do is determine whether we're working in Z or T. In this case, we were working in T because the population standard deviation isn't known. Second thing we do is find your T sub alpha over 2, then substitute in margin of error, upper and lower bound, and then finally the interpretation. Okay, I hope that helps. Let me know if you have any questions.